combustion process in CI engines. What is a CI engine basically? So if we talk about engines, they can be classified into two. One is IC and another one is EC. IC stands for internal combustion and EC stands for external combustion engines. They are very simple as the name designate. Internal combustion engines have the combustion process internal to the engines, not externally. Example are car, engine of cars, bus, bikes, etc. Whatever you see normally on the roads, they are basically IC engines. EC engines are generally used for the industrial purpose. They are bigger in size. They are used for the larger consumptions. We use steam turbines as a EC engines where the steam is produced out of the turbine plant somewhere in a boiler. So boiler plant is different from the steam turbine plant. So the firing or the combustion process happens external to the actual engine. So that is why this category is called external combustion engines. Now IC engines later on can be classified in two again, SI and CI. There are other classifications also, but this classification is on the basis of how we are igniting the fuel. Fuel is a substance which is basically giving the energy, chemical energy, into the thermal one, and this thermal is later on we are utilizing to get mechanical power or electrical power later on. So SI and CI are two broad category of internal combustion engine on the basis of ignition process. SI stands for spark ignition, where CI stands for compression ignition. In spark ignition, we use a spark plug. Generally, we use in petrol engines. What practically we say, petrol engines where we use a spark plug, which is run by batteries. Generally, in these engines, the fuel is started or it gets ignited with the help of the spark plug, means external energy sources. In case of the compression ignition engines, what we do, we just increase the pressure of the air only without using fuel in it. We increase the pressure of air, and that's why the temperature is very high. And that high temperature, we send the fuel particles. Those fuel, due to the high temperature of the air, they get self-ignited, and this process of ignition is called compression ignition process. So we'll talk about more on in CI engine combustion process now. So before this, what combustion is, the general meaning is the process of burning something. Something may be fuel, something may not be a fuel. But practically, when we go for the technical definition of it, which we can get from Wikipedia or somewhere, some other standard book also, I took just Wikipedia because it is easily accessible to all and easily understood language. Combustion, or simply normal language, burning, is a high temperature or exothermic reaction. Exothermic means it gives energy after the reaction takes place between fuel and oxidant, which is generally the oxygen available in the air. After combining this oxygen and fuel, it produces gaseous products and lot of heat, and that heat can be used to increase the pressure, and later on that pressure is utilized to get the mechanical power, and we can use this mechanical power into electricity or to convert into some other kind of energy like electrical one. So this is what the combustion is. Now, to consider how the combustion is taking place in compression ignition engine, You see this diagram. This diagram is between rate of heat release and crank angle. On the vertical axis, there is a rate of heat release, and horizontal one there is a increment in the crank angle. So if you are able to see on this diagram, there is a point A. There's a point A which is also showing SOE. It means start of injection process. In case of CI engines, we use injectors to send the fuel into the combustion chamber during the compression stroke, not after the during the compression stroke itself. So before 20 to 30 degree all around, we started injecting the fuel into the combustion chamber with the help of the injectors. If you are able to see from point A to point B, there is no heat release. So it means we are sending fuel. Since we have started already at point A up to point B, there is no increment in the release. There is no release actually. This is why, because whenever the fuel comes into the combustion chamber, there is a delay due to many reasons. And up to point B, there's no, we are not getting any heat. So this delay from point A to B generally is called ignition delay period. We will discuss elaborately later on what it is. After point V, when we are seeing that the heat is started releasing, it released rapidly. So from point to B to point C, this is a rapid increment, rapid change in the heat release. And this is because whatever the fuel which was coming from point A to point B was accumulated within the chamber, and when it start burning, all fuel particles which came between A to B started burning together, and that's why the heat release is very high and very sharp. Once these accumulated particles burnt up to point C all around, then we can say there's no large or the sharp rise in the heat release. So we can say this zone, after this sharp zone, we can say the later on the release is more controlled. So the intermediate region at which we are getting the sharp change or sharp increment in the heat. So this is basically an uncontrolled phase, which is called premix combustion phase. So A to B is ignition delay period due to the delay in started of ignition or in start of actual combustion process. Point B to C is very sharp or uncontrolled combustion phase. Point C onwards, we can see that there is no sharp rise. There is a smooth flow of energy which is converting from the chemical energy into the thermal one. And this phase we can assume up to some 195-degree angle in this diagram. So point C to D is controlled combustion phase. After point D, there is a phase which is called a late combustion phase. This phase is not very important in terms of getting the power from the combustion of fuel, because now the piston is in this stage, the piston is in the expansion stroke and the pressure is regularly decreasing and is not able to increase by the combustion of fuel. So this reason from D to somewhere E is basically late combustion phase, because, but it is essential. Why it is essential? Because if the fuel particles not burning in this phase, they will give more polluted smoke outside of the engine. So this phase is also important. So overall, we can say there are four phases, starting with ignition delay, then uncontrolled combustion, then controlled combustion, and whatever the amount of fuel left till these three phases, that fuel generally burns in late combustion phases. Some unburned fuel also gets out from the combustion chamber without taking any part in or partially taking part in the combustion process, which basically increases the pollution level. Uh, these four processes are, as I told earlier, also ignition delay, premix combustion phase, mixing control combustion, late combustion phase we have discussed. Now, since ignition delay is one of the major factors which are to be controlled to get more economic results from the compression ignition engines, we will discuss a little bit about ignition delay. So, what ignition delay is in the diagram, which was between point A and B, this delay can be classified into two terms for better understanding. The first phase is physical process or physical delay, which is because of the fuel we are sending is in the form of liquid. So first of all, it has to be mixed with the air for starting of the combustion process. So the first thing which is to be done is using nozzles, we do atomize these fuel particles. So atomization, after that evaporation of this fuel, it converts into the fuel vapor and it mixes with the air. Basically, the oxygen particles we require in the air. So this whole three things takes a time. That is one of the major factor of large ignition delay in case of the CI engine. In case of SI engine, which is spark ignition, this whole work is being done out of the cylinder itself in a carburetor generally. But in case of the CI engine, this whole three things are happening within the combustion chamber itself. So the delay in case of CI engine is more compared to the delay in case of SI engine. The second delay is called chemical delay of the chemical process, and it is the increment of the temperature of fuel up to its auto ignition temperature. So the time elapsed between these temperature changes coming into this category of chemical delay. Auto ignition temperature, to understand, this is the temperature at which a fuel gets burned without giving any external energy to it or without giving it any spark from the outside. So this is auto ignition temperature must be less for the fuel which are supposed to be good for CI engines. If it is less, in that case we can decrease the value of the time of ignition delay. So ignition delay is physical delay and chemical delay. Now we'll see some of the factors which affect this ignition delay to control the ignition delay or to decrease this time. This slide represents number of factors in which the compression ratio is the first one. Compression ratio is the ratio of the total volume of the cylinder with the clearance volume. Suppose we take two engines in which one is having more compression ratio, another one is having less compression ratio. High compression ratio means the pressure or the and the temperature both are more when we are going for large compression ratio engines. So it is very obvious if we are going for large compression ratio engine, the temperature of the air while we send the fuel is more compared to the engine which is having less compression ratio. And due to this high temperature, the time taken by the fuel from for reaching up to its auto ignition temperature decreases, and that is why the delay period is decreasing. So we can see increased compression ratio increases density, and hence closer contact of air and fuel particle. There is another way of seeing the phenomena. High density means there are more closeness between the air and fuel particle, and the chances of getting burn is more. So these two reasons basically decreases the delay period. Similarly, engine speed, as we are speeding, the loss of heat during the compression will decrease as the time decreases in that process, and due to this decrement in the heat interaction or loss of heat, the overall temperature and pressure of the cylinder is increased, and when it is increased, the auto ignition temperature is we are getting little bit earlier only, so the delay time again is decreasing. But simultaneously, what happens uh, when we have a larger speed, then the total available time for the combustion process also decreases. So that results in another negative way. We have less time, so the chances of the unburned part to get out of the combustion chamber is more. So the pollution level also rises when we are speeding, because we are not able to burn all total amount of fuel sent to the combustion chamber. We require At that time we require high power to run at that high speed. So we just compromised with the mileage or with the economy at that moment of time, also with the pollution. The third one is engine output. Uh, Engine output is increased only when we are sending more fuel and more air, and if we are sending more fuel along with more air, we are having larger operating temperature, and that's again reduce the delay period. Atomization and the duration of injection also affect it in the way that if we better atomize, the physical delay gets decreases, and that's why the delay period is decreases. Quality of fuel, which it says that if self ignition temperature decreases, cetane number increases, and uh, and that's why the delay period decreases. Practically, the way we get the octane number of fuel is just because of the delay period. The fuel which is having a less delay period is given more cetane number. So we can say we can use this line by keeping in this way that we use more cetane number fuel for better quality of the fuel, and the fuel which is having more cetane number would be having obviously a less delay period. That is why it is given more cetane number. And the last one is the intake temperature and pressure. In different atmospheric condition, we have external temperature varying from one region to the another region. So simply we can compare Kashmir to Rajasthan or these tropical areas. So these there is a various changes in temperature and pressure, and due to this external temperature and pressure change, this is also affecting the delay period. If the temperature outside temperature is high, then obviously the delay period will be less. So this was the combustion process, how the combustion process takes place in the compression ignition engines. In next lecture or next time, we'll deal with the spark ignition combustion process also. Thank you.